So today we're going to be doing the instructions for our last lesson. So I want to let you guys know, like, you guys are surviving this. This is tough. Some of you guys are super overwhelmed right now with math. This is the worst unit of the entire school year. It's like that in the classroom. If we were in regular school, it would be the same way. So I don't want you to think it's because of we're online. Like every year we come back from winter break and this is the chapter we do in school. And this is by far the worst unit that students do across the board because it is a lot of material. It's a lot of stuff you've never seen. So you are not alone. Don't get too overwhelmed. I promise you after this, you're going to have some time to breathe. You're going to be learning new things, but it's not as in-depth as some of this stuff. So again, across the board, everyone will tell you who's taking pre-cal, this is the worst of it, the worst unit that there is. These last few sections with all the half angles, double angles. Today we're going to be solving equations. But we're almost done. By next Friday, you guys will hopefully have taken your test and you could be done with Trig, and we're moving away from Trig. So there is some light at the end of the tunnel. I want you to know that you're not alone. I know that it's hard doing this all online, especially with the edgenuity, but most people struggle in the classroom with the teacher when we do this. So again, I just want to reiterate that, especially if you're having feelings of being overwhelmed. I understand. I wish I was there to help you guys through this a little bit more. So I am going to get started with our last lesson for instruction. Turn in your notes as soon as you can, and I'll work on trying to grade some of them this weekend and get it all taken care of. But this is going to be trig equations day 1. So this is going to be based on the instructions. This lesson is kind of a little bit of a review for you guys for some of it. Hopefully this looks familiar to you guys. This is exactly what I had done. I believe this was last semester. So it was the end unit going into winter break. This is the exact same tables. I copy and pasted it to my notes. And I wanted to go over this so that you guys had a fresh little copy of this, because this is going to be the stuff you're going to be using. You need to know the domain and ranges for these because we're talking about our arc sine. We're solving equations. It's all about solving these equations. And when you solve for an angle, you're using your arc sine. And remember, that's the same thing as saying sine inverse of x. Remember that notation is interchangeable. And so I thought it would be really important for me to just kind of help you guys remember why the answers are the way they are. I will note this stuff. I don't think that they use any of the reciprocals. I'm pretty sure it's only these 3. So maybe I won't even spend the time on that. I'm pretty sure that doesn't come up. I'm going to say that and then something's going to come up. Actually, I see one that uses cosecant, so I will go ahead and address it. Remember that this inverse is not the same as saying 1 over sine of x. It's not saying that that's bringing it down to the denominator. This inverse notation is saying arc sine. You use it when you solve for the angle. Is not the same as 1 over sine of x. So be careful about that. So when we talk about arc sine, it cannot be in quadrants 2 or 3. It can be in quadrant 1 or it could be in quadrant 4. Now, when I say this, I say from 0 to pi or to a negative pi over 2. Some of you guys go, well, why can't I say 3 pi over 2? Well, that's because if I was going to go to 3 pi over 2, I would have to go through the zone that we said, no, it can't be. So when we talk about my solutions for this, it's going to be from pi over 2 to negative pi over 2. So I just kind of want to remind you guys that the domain is going to be from -1 to 1, and the range, my solutions are going to be from pi over 2 to that negative pi over 2. And that's going to be very similar for tangent. Remember, tangent and sine are the same in regards they can't be in quadrants 2 or 3. So this is going to be my pi over 2 to negative pi over 2. When we talk about tangent, though, the tangent inverse is going to be all real numbers for the domain, but my range is still being limited, my solutions to, I wrote this wrong, this would be proper notation. a negative to a positive. So I do want to point that proper notation out. So this again would be negative pi over 2 to my positive pi over 2. Now cosine was the one that was different, and for cosine it can't be in quadrants 3 or 4. It's going from 0 to pi. So my domain is going to be from -1 to 1, but the range is going to be from 0 to pi. So this one's a lot prettier to work with, a lot easier. Again, remember, it can't be 3 pi over 2 here, even though this is at the same spot as my 3 pi over 2, because I can't go from 0 to 3 pi over 2 without crossing into the zone that I said, no, it can't be in, you can't go through that. So also just as a reminder, I'll go ahead and give you these values. My domain is going to be negative infinity to -1, union 1 to infinity. My range here was going to be from negative pi over 2 to pi over 2, with the exception that y cannot be 0. So I want to have you guys have this just in case you're going to need it across the way. We don't go to this as much as we do our just regular arc sine, arc cosine, and arc tangent. These are going to be our main go-tos. But just so you can have it handy in case if we do need to look at this information. My range is 0 to pi, and y cannot equal pi over 2. At these values is where you're going to be seeing asymptotes. Oh, and I did another mistake that I should make sure to point out. Remember for my tangent, remember at those negative pi over 2 and pi over 2, we have the lines. I don't know if you guys remember our tangent graphs where they were kind of, and then went something like my lines went like that because I had my asymptotes here. So remember, I couldn't include those values. That's because those are where we have our asymptotes. So they're on the graph at our negative pi over 2 and at our positive pi over 2. So just so you can see, when it's not these values, when it can't be these values, that's because there's probably an asymptote there. It could be anything else. It gets super, super close to it, but there's going to be our asymptotes there. And then my last one right here, my cotangent, my domain is going to be all real numbers. The range is going to be from 0 to pi. All right. So this is just kind of some background information. So you can see, well, when we solve for these angles, what is our answer range going to be? So let's go ahead and get into this first one. It says, which of the following is the value of sine inverse of the square root of 2 over 2? So if we're looking for sine inverse of the square root of 2 over 2, that's the same thing as saying arc sine of the square root of 2 over 2. So that's interchangeable notation. So that's going to be, well, remember, if it's going to be sine, if it's going to be a sine value, then I know it cannot be in quadrant 2 or 3. It has to be a value from pi over 2 to negative pi over 2 here. Why is this so important? So here's what they're doing. Remember, sine is our y value. We've been doing this over and over. And I'm looking for, where's the y value going to be the square root of 2 over 2? Square root of 2 over 2 and square root of 2 over 2. It happens at 2 spots, right? And so if you were looking to see, well, where is sine going to be square root of 2 of 2, then that's correct. But when you're solving for the inverse, when you're solving for the inverse, so if they ask you to solve for that inverse, if it's set equal to 0, most of the time you'll see something like this where it's set equal to 0, then you are solving it. And when you are solving it, it cannot be in quadrant 2 or 3. So when I look here, this value is in quadrant 2, and we said it can't be over here. So the only answer, you would only have one solution for these, is going to be this value here at 45 degrees or at pi over 4. So I look here and my answer, so it's the same thing, it's at 45 degrees or pi over 4. So I look here, we're using radians, so this would be my correct value. This would be the value I want to use. All right, so let's look at another example. Tangent of -1. Tangent inverse, sorry, of -1. Tangent inverse of -1. So if I want tangent inverse, then I know tangent inverse, I cannot be in quadrants 2 or 3. My answer has to be between my pi over 2 and negative pi over 2 there. Has to be between here and here. So I'm looking to see when tangent inverse is -1. Remember that tangent is going to be my y over my x value. So I'm looking for my y over x to give me a value of -1. So I look here, and I know it's going to have something to do with my square root of 2 over 2 and square root of 2 over 2. They're going to be the same, right? And I want it to be a negative, so I'm thinking it's going to be this piece right here. And what that's telling me, if I have a negative square root of 2 over 2 divided by a square root of 2 over 2, if they have a common denominator, I could cancel that out. Negative square root of 2 over 2, square root of 2, that's the same thing divided by itself, is just a -1. Again, same thing divided by itself is just -1. However you want to look at it, it's a value of -1. And this happened, so on my unit circle, square root of 2 over 2, negative square root of 2 over 2, happens at 315 degrees, which is 7 pi all over 4. But the problem is I have to have a value, 7 pi over 4 is greater than pi over 2. I have to have a value between these two numbers. So yes, 7 pi over 4, that is correct. That's not a wrong value, but that's not within the range. So I need to figure out what is the value from here to here. Well, that's just going to be a negative pi over 4. Somebody's like, well, how do you get that? Well, that's because from here, if this is 7 pi over 4, this has to be 2 pi, right? Which is my 8 pi over 4. So that difference is a difference of pi over 4, and I'm going in the negative direction. It's that simple. Don't overthink it. All righty. For this one's pretty easy. They have it worked out for you, but I want to show you how to do this graphically. So some of you guys might want to use your graphing calculators for this. You can use Desmos for this. So they did the work here, and really, so if it's cosine, I know I'm going to be in quadrants 1 and 2, and I'm going to be looking in here to see what is going to be, what's going to work over the given domain. Let me show you this graphically. So it's telling me here, so when I go do this graphically, I do want to point out it's saying for 0 to 2 pi. So let's look at this graphically. I'm going to share my screen, different screen. Let me go ahead and share over here. Desmos is a great tool. Did it share it with you guys? Okay, good. Okay, so here's what I would do for this. So the problem was 2 cosine, so I'm going to type it in, 2 cosine of x minus the square root of 3. So I'm going to go ahead and do the square root of 3. All right, so I see it on here. I don't like the way that all of this looks because when we talk about this, we're working in pi. So I want to make sure that I'm in radians and not degrees. So I need to look at some of this information. I'm going to need to move some of the stuff out of my way. So I'm going to go to my settings here, and I want to make this look a little bit better. So when I work with this, I want my y-axis to be from 0. Oh, actually, I want my x-axis to be from 0 to 2 pi. Because remember, that's what they told me x is between 0 and 2 pi. Now, you can see that I have a pi symbol right here, so I could go ahead and use that. And then I'm going to make my step a value of pi so that it's broken up not by 1, 2, 3, just counted by ones, because I like to see the pi values to help me be able to read the graph. So I'm going to go ahead and make sure I check that. I have radians already selected, so I'm good there. If it was in degrees, you would want to make sure to check it. So I have it in radians, and I'm going to look here now at my graph. And this is actually really nice to look at. So this is at 0, and it went to 2 pi. So it's focused on where I'm looking, and I'm looking at my pi values. And my solution, if I'm solving this, I want to know what is x equal to. That's what we're looking for these. When we go on our unit circle and we're solving for that, we're looking for the x value. So when I look at this, I can go ahead and I can see, look, I crossed at pi over 6. So when x is pi over 6, and I can see this other point right here was at 11 pi over 6, at 11 pi over 6. So when I go and I look at my actual problem, so you can see at pi over 6 and 11 pi over 6, and I look at the actual problem, I have those two answers, pi over 6 and 11 pi over 6. Both of those will work. Both of those will work. So I was able to just graph it and come up with the answer without having to do all the work. I didn't need to solve for that value. I just plugged this whole thing. As long as it was set equal to 0, I was able to just plug it into my calculator. So make sure to note, in order to plug in the calculator, it needs to be set equal to 0 for your calculator. But that was pretty easy to see, I think. So once you change it into your settings in regards to 0 to 2 pi, and you put it in your step as pi, you can keep plugging in different graphs into there. You don't have to reset it each time. Do I have any questions before I continue? All right. So my last one, we've already done factoring with values like this, but I want to show you, they kind of do it in a little bit of a different way. So they do what we call USubstitution. So it's the same idea, but they're trying to help you guys be able to break it down and look at it a little bit differently. So if I have this equation and they ask me to solve this, they're saying let u equal sine of x. If this was cosine values, and they would say, hey, let u equal cosine, or let u equal tangent of x, whatever it is. So if that's the case, if I let u equal sine of x, then I could rewrite this as 10u squared, because this is sine squared, minus 3u minus 1 is equal to 0. And the reason why they have you do this is because when you guys look at this quadratic equation, it's easier for you to factor. So I like to use my magic X. So I go, okay, I need two numbers that multiply to a negative 10 and add to a negative 3. So the numbers would be negative 5 and positive 2. Now, don't forget, we have a coefficient with 1, so this is a value of 10. So we're dividing this by 10u because that's a 10. And I need to simplify. So this becomes 1 over 5u. This becomes negative 1 all over 2u. So the factors are 2u minus 1 and 5u plus 1 is equal to 0. So the first question says the given equation is equivalent to what? So this is the answer. You'll have a drop down so you can see. watch your signs. That's usually the biggest mistake, are your signs. This is something that's easier for you guys to look at factoring versus this. This throws you guys off just with the different notation. Okay, so if I have this, then this is the same thing as saying 2, instead of 2u, it's the same thing as saying 2 sine of x minus 1 is equal to 0, right? Why is it equal to 0? Because our zero product property says we could set each one of these pieces equal to 0. But if u is sine of x, then I could plug it in. I also have then 5 sine of x, because u is sine of x plus 1 is equal to 0. If I want to solve for sine of x, because they want to know what is sine of x equal for this factor, then I add 1 to both sides. 2 sine of x is equal to 1, divide by 2. Sine of x is equal to 1/2. So for this piece, it's just 1/2. Over here, same idea, subtract 1 from both sides. 5 sine of x is equal to -1. Divide both sides by 5. Sine of x is equal to -1/5. So this is going to be a -1/5. And you're done with that problem. This is actually a separate problem. So that's all they wanted you to do. You didn't need to do anything else. That's it. All right. And then my very last problem. They want me to solve this. This looks horrible, doesn't it? So some of the things when I solve, I look for Pythagorean identities. I might need to change things into terms of sine and cosine. So let me give some hints. So look for your Pythagorean identities. So sine squared plus cosine squared equals 1. 1 plus tangent squared theta is equal to secant squared theta. Those are your Pythagorean identities. The other thing is to change terms into sine or cosine. That, because usually you might be able to simplify things. These are just some hints. It doesn't mean it's always going to work out that way. Okay, so I'm looking for answers that are going to be from 0 to pi over 2. So we're looking for quadrant 1 answers. I know I'm only looking in quadrant 1. So here's what I start with. Sine squared x is equal to, sometimes I like to write it without the parentheses because I feel like it just confuses my eyes. It's so much, is equal to my sine of x secant of x minus cosine squared of x. So right away, I kind of get my eyes paying attention to this sine squared of x and this cosine squared of x, because I know that's a Pythagorean identity. And that Pythagorean identity is sine squared of x plus cosine squared of x is equal to 1. And I'm like, well, what if I move this sine squared of, or cosine squared of x over with my sine squared of x? And when I do that, I get sine squared x plus cosine squared x is equal to sine of x secant of x. And this is fabulous because I know that this right here is my Pythagorean identity, and that this whole thing right there, this right here, is equal to a value of 1. So that 1 is equal to, well, now I still have this. So I'm like, okay, well, I know sine of x, I know secant is 1 over cosine of x. So I could rewrite this as 1 is equal to sine of x all over cosine of x. Well, that should be familiar. That's just tell me 1 is equal to tangent of x. So I'm looking to see, when is tangent of x going to equal 1 in quadrant 1? Yeah, at my pi over 4, which is square root of 2 over 2, divided by my square root of 2 over 2, that's going to happen when x is equal to pi all over 4. Show you guys it right here, my unit circle. If I take this value, tangent of pi over 4 is just a value of 1. And that's what we're looking for. It said quadrant 1, and there's my answer. This is the answer they're looking for, and you're done. All right, again, a lot to take in. Today's just instruction. Tuesday is the assignment. Wednesday is the review, or is the quiz. And then Thursday and Friday, I will go over questions from the test review. The test is scheduled for Friday. So make sure you get your guys' notes in by Tuesday. So this was the last lesson. You could turn notes in now, but by midnight, 11:59 Tuesday night, they are due if you want 5 points extra credit added to your quiz. Do I have any questions before you guys go today? You have a great weekend. If you guys need anything, send me a message. I'm going to be gone for half the weekend, so I'll be able to get back to you on Monday night, or today, tomorrow morning, I'll still be around. Otherwise, you guys have an amazing time, and I will see you guys next week. Take care. Thank you.